Right, we're going to be doing 10.2, multiplying rational expressions. And when you multiply rational expressions, you multiply the numerator, then you multiply the denominators. So let's look at a couple of examples. Let's start with this one right here. We would multiply the numerators across the top, then the denominators. So 2x times 5 would be 10x, and 3 times 7 would be 21. I can't factor anything out of those two, so that would be my answer, and I would circle it so that we knew what it was. All right, so another problem, multiplying again. And if we're going to multiply 5a over 4 times 2 over 5a, again, we're multiplying the top, the numerator, by the denominator on the bottom. And you can simplify if you're comfortable with that. If not, multiply straight across and then simplify. So 5 times 2 would be 10, a to the third. 4 times 5 would be 20, a. I know I can divide 10 by 10 and 20 divided by 10. So 10 divided by 10 is 1, 20 divided by 10 is 2. So I know I'm looking at 1/2. This is 1a and this is 3a's. And remember, when you have the a's on top in the numerator and an a on the bottom in the denominator, you subtract the exponents. So 3 minus 1 would be a to the second power. Okay. And that's a positive a to the second power, or excuse me, positive exponent, so it would be up on the top of that fraction. All right, let's look at another one. This one, 4 divided by 5x squared times times x minus 2 divided by 2x to the third. So again, we're going to multiply the denominators and the numerators. So 4 times x minus 2 on top, and 5x squared times 2x to the third on the bottom. Okay, so now, once we've got that set up, we could distribute the 4, but before we distribute the 4, I want to see what else we have. So 4x minus 2. And down here we multiply the numbers. 5 times 2 is 10. And we multiply the x's, x squared and x to the third. Two bases with two exponents, we add the exponents. Now, I'm kind of glad I didn't distribute, because look at this. I can take a number out of both of these. I can take a 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So I get 2 times x minus 2 over 5x squared. Or excuse me, x to the fifth power. Now, I don't have to distribute, and what I would suggest on an assignment is double check the answer. If they show that they want you to distribute, then distribute. But this would be sufficient at this point. Now we have a minus 2 divided by 3 over a plus 2 divided by a plus 3. So again, multiply the top, multiply the bottom, multiply the numerators, a minus 2, a plus 2. All right. On the bottom, 3 times a plus 3. Now I'm going to tell you right now, that's the answer. If you look, there's nothing I can take out of the top or the bottom. This is a plus 3, but this is a plus 2. This is subtraction with a 2. This is a 3. I'm done. Our last problem, negative 2 divided by 2y plus 6 over 3, or excuse me, times 3 divided by y minus 5. Again, multiply the top, negative 2 times 3 on the top, and then 2y plus 6 on the bottom times y minus 5. I'm going to multiply this. Well, maybe not. Let's not multiply it. Let's see what we can take out of these two, because I happen to notice that they're both even. So I can take a 2 out of both of those. I'm going to leave the top just as it is right now. And when I take the 2 out, this is 2 times y plus 2 times 3. So I take that 2 out, and I'm left with y plus 3 times y minus 5. Here's a 2 and a 2. So negative 1 times 3 is negative 3. And down here we have y plus 3, y minus 5, and we are done. We cannot move this 3 because it's attached by a positive or a negative. If it's added or subtracted from something else or to something else, I cannot separate them.